So this video is all about properties of molecular compounds. Just to remind you what a molecular compound is, it's a compound where you have covalent bonds between your atoms. So covalent bonds means you're sharing electron pairs. So maybe we're talking about something like carbon dioxide, right? Carbon brings 4 electrons to the situation in its valence shell, and oxygen brings 6. And instead of anybody giving an electron to anybody else, these electron pairs will actually just be shared. So these two will share. The carbon and the oxygen will share both of those pairs. That's a double bond because there's 2 shared pairs. And on the other side, we'll have another oxygen bringing in 6 electrons. And that will also share 2 pairs with that carbon there. So now if we zoom in on the carbon has 8 valence electrons there, including the ones it's sharing with oxygen. And if I zoom in on either oxygen, that oxygen has 8 valence electrons. And this one has 8 valence electrons. And a full valence shell is 8, so everybody's happy here. Nobody had to actually give away an electron to do that. They're sharing these pairs. That's how they've made their 8 valence electrons, their full valence shell. And so that's how the bond is forming for a covalent bond, which makes molecular compounds. So the state of molecular compounds tends to be soft solids, liquids, or gases at room temperature, unlike ionic compounds, right, which tend to be those hard, brittle crystals like salt. Molecular compounds are softer, solids, liquids, gases. Solubility in water, they can be soluble or non-soluble. What it comes down to is their polarity. We'll look at that in this video. They tend to be poor conductors of electricity, and that's because you need ions to conduct electricity, right? You don't have any free-floating ions with a molecular compound, so the electrons are all still attached to their atoms, right? They're just being shared within the molecule. You don't have a freestanding positive and negative charge alone, so it doesn't conduct electricity well. They have lower melting points than your ionic compounds. And all organic compounds, so that's matter that has carbon as a backbone, that includes a lot of what you're made of, what life in general is made of, is a lot of organic material. Those are often molecular compounds. So how do you know if a molecule or a molecular compound is soluble in water? So what it comes down to is polarity, and the rule is that like dissolves like. So what that means is if you have a polar molecule, like water, right? Water would be a polar molecule. That will dissolve other polar molecules. And non-polar molecules will dissolve non-polar molecules. So for example here, a polar molecule here would be water. So this is like water. Will dissolve any kind of a polar molecular compound. And a non-polar molecule would be like oil. Oil will dissolve any non-polar molecular compounds. So if you want to know, well, what will dissolve in water versus what will dissolve in oil, you have to look at the polarity of your molecule. Polar ones dissolve in water, non-polar ones will dissolve in oil. So why is this the case? Let's zoom in on an example. So this is hydrochloric acid. Hydrochloric acid is a molecular compound. The chlorine has a higher electronegativity than the hydrogen, so it's going to hold the negative charges closer to it. That shared electron pair is going to be closer to the chlorine than it is to the hydrogen. So that makes the chlorine negative, and the hydrogen is going to be left a little bit positive. So if water comes in and sees this polar molecule, well, all of the positive ends of the water, so that's the hydrogen ends, this is hydrogen, right, hydrogen, they'll come in close to the negative chlorine end of the hydrochloric acid. So here's all our water molecules coming in. Then we've got the negative oxygen end, so this is oxygen here, it's going to come in close to the positive hydrogen end of hydrochloric acid. And so that's how this polar molecule of HCl is getting dissolved in the polar molecule of water. So like dissolves like, polar water is dissolving polar HCl. Now, if you look at any kind of a fat or an oil, those don't dissolve in water. because they're nonpolar, and like dissolves like. So nonpolar is not going to dissolve in polar. But fats can dissolve, or oils can dissolve other nonpolar molecules. So oil can dissolve nonpolar molecules. So an example would be like benzene. Benzene is a nonpolar molecule. It looks like this. It's 6 carbons in a ring. And it's something like a single bond, double bond between them, but it's actually a little bit messier than that in real life, but that's how I'll draw it for now. And there's hydrogens around the outside. So this is benzene, very nonpolar, right? The bond between carbon and hydrogen, if you look up the electronegativity difference there, it's less than 0.4. So that's not even a polar bond, and the thing is also symmetrical. So definitely a very nonpolar molecule all around. Benzene will easily dissolve in oil. So this is benzene. Dissolves with oil. So oil and benzene will easily be soluble with each other, but benzene won't be soluble in water, right? Because water is polar, benzene is nonpolar. So nonpolar things like benzene, so this is a nonpolar benzene, will dissolve with nonpolar oil because oil is nonpolar, benzene is nonpolar. Like dissolves like, so polar dissolves polar. Molecular compounds don't conduct electricity like we said, and that's because they don't have any free charges. You have to have some negative charges that can move around, right? That's electricity in a wire is moving electrons, right, through that wire, slowly drifting down the wire. If you don't have any charges, you can't conduct electricity. So you're not going to be able to conduct electricity easily through a molecular compound. It's more of an insulator.